All right, let's get started. All right, so PS6 is out there due end of the week. The following week is fall break, and the week after that is midterm week. So I haven't said much about the midterm yet. I will now. The midterm is on October 16th, and where you go and when you go depends on things. It's given here. So if you're in the regular section, the lecture section, section 1, you come to here at 3 o'clock as normal if your last name begins with A through P. If your last name is Q through Z, go next door to L103. This gives us more room to spread out. And then the hybrid section, it's the exam for that is from 5 to 6:20 in here. And if it's any kind of a problem to attend, let me know really soon. The exam covers the first 6 weeks of the semester, which ended on Friday. So that there were 11 lectures, 6 labs, 6 weeks of Zybook, and PS1 through PS6 are all included in the exam. But bring your ID to the exam, because when you hand in your exam, we will check your ID. You can bring one sheet of notes. So you 8.5 by 11 standard sheet of notes, front and back, printed out or handwritten, whatever. You can bring and refer to during the exam. One thing to realize is that you'll be writing some code. You won't be writing large amounts of code, but you'll be writing some code. You're not going to have Eclipse to help you. So the things that you usually rely on Eclipse to remember for you are good things to put on that sheet of notes. I have posted 2 old midterms on the course schedule for week 8, and I'll eventually post the solutions after you've had time to look at the exams themselves. We'll discuss the solutions to those 2 exams in lecture the 2 days before the exam, and also in lab 1 day before the exam. One thing about the sheets of notes, you'll need to hand them in when you hand in your exam. So if they're if you want to keep them, make a copy before you come. Students ask me what's the important thing to study. I think one really important thing is to make sure you understand all the code examples from class, from the labs, from the assignments. So go back through lecture and look at old code examples, look at the assignments. I haven't got it organized yet, but I'll put up solutions to the assignments so you can look at those too. PS7 will be due the week after the midterm, but it will come out. I'm hoping to have it come out like probably this weekend. So if you basically have 3 weeks to do it. If you want to, so you can do it right away or wait until the last minute as usual, whatever. Any questions about the midterm? Yeah.
Will there be TA office hours over fall break?
No, there won't be any office hours over fall break. And limited TIs are answering. You have questions?
Sorry, so you said 3 weeks until the exam happens, right?
No, 3 weeks until PS7 is due.
Oh.
The exam itself is 2 weeks from Wednesday. Yeah?
Do you care if our notes are typed or handwritten?
Nope.
Don't care?
Don't care.
Cool.
Yep.
It says front and back.
Front and back. Okay. Any other questions? Yeah?
Sorry. So are you going to post the solutions to PS1 through 6 on Canvas or no?
I'll put the solutions, they'll be on Canvas. You can get at it through the CPM or however you usually get things off Canvas. Anything else? Okay, so you'll see. I won't try to describe what the midterm looks like. You can just look at it online, and I've given you the 2017 and 2018 midterms, and so 2019 will be similar. Incidentally, we grade those midterms on GradeScope by taking your exams and scanning them in and then grading them. And it works amazingly well, but only if you write in the boxes. So you'll see the exams I often put, or almost always put little boxes where the answer is supposed to go. And what doesn't work is to write the answer over here and draw an arrow to the box or something. We just see what's in the box. So put the answer there. Okay. I briefly want to talk about this problem here that we didn't finish last week. And you remember, the idea was we have a table like this, and the table has headers. So this column has a header name, city, age, salary, and then all the rest of the rows contain values that go under the headers. And we want to be able to answer questions of the form, okay, if you look at everyone who is from Salt Lake City, what's the average of their salaries? Or everyone in New York City, what's the average of their age? Questions like that. And to do that, we have this method here, conditional average, that takes in a scanner which is going to read the table from. So the table will be formatted like I just showed you. The condition header there's a condition header and a value header. So up here it might be, the condition header might be city, the value header is salary. So when we ask a question like, for a given city, so for Salt Lake City, what's the average salary? City is the condition header. Salary is the value header. And then there's a condition value we give, that would be Salt Lake City, SLC. So we go in the column of the condition header, we find every row that contains the condition value in it under that header, and then we go over and average the corresponding salaries in this case. And this is the code that we wrote. And the first thing we realized is we needed to find out the index in the header row of the condition header and the index in the header row of the value header. So it basically had to know in which column was the condition header, in which column was the value header. And you think about it, it's basically the same problem, just with different values. So we invented a method called find column index, where we could give it the header row and a condition header. So we give it this row and the header city, or that row and the header salary, and it'll tell us what column it's in. So what we didn't get around to is implementing that method. Now I've partially implemented it here. And the first thing I want to call your attention to is this right here, because this will actually prove valuable in the current assignment. Who could tell us what split does? Split is a method for strings. What does split do? Yeah.
Splitting the string into the value.
Okay, so it splits the string into an array of pieces. How does it do the split? How does it know where to do the split? Yeah.
Wherever it sees the value you give it, it'll split it there.
Okay. Wherever, in this case, it splits it on tabs. So it's saying everything before the first tab is the first thing in the array. Everything up to the next tab is the next thing in the array, and so on. So it splits along tabs. And the truth is that parameter is a regular expression. Regular expressions are a fairly involved topic I'm not going to go into. But if you want to split on tabs, that works. Yeah.
Does it split at every occurrence of the tabs, or just at the first one?
No, if there's, let's say there's 4 tabs, you're going to get back an array of length 5 that has the stuff before the first tab, the stuff up to the next tab, and so on. And then the last bit's the stuff after the last tab. Yeah?
Does splitter use white space?
Split uses, the way I've written it right there, it splits on tabs, not on white space.
Okay, I was just wondering if it were possible to do white space. I know that.
If you know how to use regular expressions, you could tell it to split on any white space. Okay? But in fact, I'll show you how. That would split on white space, because the regular expression \s means any white space, and I have to escape the backslash. But that's good enough for our purposes right there. Okay, now, why would this be used for PS6? Yeah?
Well, because it has the NFL and the states
Okay, so you have tab separated data that you need to pull apart. Now, why not just use a scanner? All right, if we gave, okay, assuming these are tabs right here, if we gave that to a scanner, it would give us back name, city, age, salary when we went through the tokens. So what's the reason for using split? I can think of two reasons to use it. Yeah.
Does it take up more resources?
Say what?
Does it take up more resources?
Yeah, actually, scanners are a little more heavyweight solution. Take up more resources. That wasn't one of my reasons, but fine. Yeah.
Cleaner code?
Cleaner code, perhaps. Yeah. I think it does lead to a cleaner solution. Yeah.
It's easier to assign things to other things within the breaking
To send things to other things.
to like make an array of something. Like say that name John name Marines.
Okay. All right, so that was, I think what you're saying is something I had in mind. When you do the split, you get the whole array back. And then you can access the array in any order you want, as opposed to a scanner just gives you a token at a time. The other one, which Noah has mentioned, is suppose that this table, the header here were name of person, tab, city of residence, tab. With split, you would get name of person as one chunk. What would happen if you used a scanner and went next, next? You'd get name as one thing, of's another thing, person is another thing. So if you want to split just on tabs and not on white space, then split's good for that. Okay, so we've split the header into this. We split the row into its headers, and we want to find out in which column, counting from 0, does this string right here occur, this header occur. So how do we do that? In other words, what goes right here? What kind of loop are we talking about? Accumulation, searching, optimization? Searching loop, right. We're searching for this header in this array. So let's do this. Okay, we'll go through, and I need an if statement. What if statement do I need? The idea is we're looking for that header. When we find, we're going to return its column number, which is just going to be this index I. In fact, let's leave it I. That'll be the column number. All right? So how can we tell if we found what we're looking for? Yeah?
Headers at index I equals header, the variable.
Eclipse does not want me to use equals anymore. I think it must prefer content equals these days. I got to find out why. There's probably some reason. And what do I do if I find the header?
Return I.
All right, we found it, so we return I. And if the loop ends, we're going to throw the illegal argument exception because it says to do that right here. Okay, so that's just a simple use of using split to get an array of strings, and we search through and we return the column number. And then there's a little bit more to the method, but I'm not going to go through that. It's sort of more of the same. I'll see if any questions about what I've done here. All right, so we're getting to the point of the course where, yep, we've been studying loops, but we're moving on to other things. But it's just another tool in your toolbox now. When you need to, you need to be able to look at this problem and say, oh yeah, I've got to write a searching loop that goes through the array looking for header. And then hopefully, when you realize that, that's the hard part, and then it's just a matter of typing out a familiar pattern. Anyway, that should be your goal here, is become familiar enough with this so that it's not a big deal to implement a method. Okay, now I spent a few hours yesterday looking at implementations of the generator class. And I saw all kinds of interesting implementations. So I thought I would implement it here and show you my thought process when I do it. And it ties into that example we just saw. That example was sort of about the use of helper methods. So presumably you know what the generator class is supposed to do. So I'm just going to dive in. So when I'm looking at this problem, I'm thinking, okay, what have I got to do? Well, what is the first thing you have to do? Yeah. Yeah.
Create for the generator, you create like three different variables, right?
Okay, so I've got to get three pieces of input. I've got to get a level, a length, and a file. And once I've got that, I can do a fourth step, which is actually generate the text and display it. So when I'm looking at a main like this, I don't think, okay, that's a lot of stuff to write. I don't just go, okay, let's see. I saw an example like this in class that started with while true, so maybe I want to do that. And I know I got to catch an exception, so maybe I put a try block in. No, you don't want to do that. You want to think, what I do is I think, okay, there's four steps. Get the level, get the length, get the file, display the answer. So I will think, okay, let's get the level, and I'll just invent a method called getLevel. Right? It doesn't exist, but I'll get around to that later. So I want to get the level from the user. And then I need to get the length. So I'll invent a method to do that. And then I'm going to have a method to get the file. And suppose I have the level, the length, and the file. What do I do then? Yeah? Okay. We need to call, what was it called? PS5 .generate text. And it wants a scanner, so I better do that. And maybe I better, okay, now what? Okay, I've generated the text, I've got the result right there. What's the last thing I need to do? Yeah. Okay, now that's just a quick rough draft of my main method, just trying to figure out what it is I need to do. So it looks like if I could figure out those three methods, and there are going to be some corner cases to worry about, I'd be a long way towards solving the problem. But that's what a main method ought to look like. Nice and short, easy to understand, and farm off the details to the helper methods. If you insist on putting every scrap of code in the main method because you don't want to implement a helper, you get code that's really hard to understand and hard to debug, especially when you start having problems and your reaction to solving the problems is to make the code more complicated. Very often the reason your code, the right way to make your code work better is to make it simpler. Okay, so what should I do next? Yeah? Okay, I could make a method for each one of those. All right. Well, let's go make a method for getLevel. So I'm going to ask it to create the method for me. And I need to describe what it's going to do. Gets a non-negative level from the user. Maybe I'll say prompts provides a non-negative level, which is returned. Now, what detail have I left out there? Besides, I mean, I've left out some detail. You know, we can't have negative numbers. We can't have garbage. I'm sort of assuming you understand the problem right now. But what else do I need to say? You've implemented this class, generate class. Yeah.
You have to also talk about the exceptions.
Okay. Well, we got to. Is there any exceptional behavior? Or more to the point, if you're using getLevel, yeah, you expect an integer back. What else do you need to be able to know about, though, besides what integer the user entered? What needs to be communicated back to the user besides the integer entered by the user? Yeah.
If the user presses cancel.
Right, if the user cancels. But if the user cancels, what should we do? Well, that's just a design decision. What should we have it do when the user cancels? We get to decide. And a lot of you had it return to -1, right? Because that can't be a correct return value. What are some other things to consider? Yeah. Okay, well, I'm not asking you how to do it. How does the caller of getLevel know? How are we going to tell the user of getLevel that there's been cancel? Yeah.
Throw a null pointer exception.
We could throw a null pointer exception. We could return -1. We could throw some other exception. Lots of choices. I'm going to have it throw a null pointer exception. Now, I don't particularly like it throwing a null pointer exception, and I'll tell you that if I were doing this for real, if I wanted to throw an exception to indicate cancel, I would go create a new exception called cancel exception and throw it. Okay? Because a null pointer exception could be any kind of error that happened to involve a null pointer. The exception ought to have something to do with what we're trying to signal by throwing it. And so I would prefer to throw a cancel exception, but I don't feel like showing you how to create new exceptions just now. So we'll just use one that pre-exists. Null pointer exception. Okay, great. So here's where we're going to have to do something repeatedly. So I'm going to say while true. And I've got to go get a I'll do something like that. So we're going to display the input dialog and get back the reply. And what do we do if the reply is null? That means the user is canceled, so what should we do? And again, I'd rather throw cancel exception, but what can I do? Okay, that's good. What do we do next? Assuming it wasn't null, what should we do? So we should parse it. And I guess we ought to save this. Okay. Now what can go wrong with that? Yeah?
If you try and convert like strings or chars into inputs, it's gonna throw
Okay.
an exception.
It could be that my reply right there is not an integer literal, and that it doesn't parse as an int, and a number format exception is thrown. That could happen. How can we cope with that fact? What are we supposed to do if there's a number format exception? We're supposed to ask him again. So I'm going to put this in a try block, because in Java the only way to find out it didn't parse is to catch the exception. So number format exception. And we'll figure out what to do about that later. What else could happen? Okay, if level is negative, we've got to do something too. And what if it isn't level? What if level is not negative? Right, we can just return level. We've got our int. Okay, so let's see what we have here. We've got this loop that's just looping, reprompting until we get an answer we can live with. One answer we can live with is if the user hits cancel, so reply is null, so we throw that exception. That's one way to exit the loop. Otherwise, we're going to parse the int, parse the reply we got into an int. If that fails, we'll be down here to do something, but we're still inside the loop. Otherwise, we've got it parsed. If it's negative, we do something. Otherwise, we return the level. That's another way we get out here. So what should we do here if the level is the negative? Yeah?
You're supposed to tell them to enter a non-negative.
Okay. We could display a message here. Okay, and what should we do if we get a number format exception? Okay? Same sort of thing. And there we have it. So we have our get level. It's just a while true that each time through it prompts, and sometimes it throws an exception, and sometimes it returns, and sometimes the loop continues. And that reads in our number for us. And we can try it out up here. I'm going to comment out this stuff here so I can actually experiment with it. So the advantage of doing it that way is, at this point, you can experiment with the method and see if it works without having the rest of the main method written. It says enter level. I'll type some garbage. It says non-numbered enter. Try again. -1 doesn't like that. If I cancel, aha. Okay. When it canceled, we have an unhandled exception, the null pointer exception, which is what we wanted. And if I enter a good level, then it just works normally. So it seems to be working okay. So that's good. Now I'd be tempted to come back in here and put some inline comments sort of explaining what's going on, some / comments, just to break up all the code. But in the interest of time, I won't do that. What's next? Okay, we need a getLength method. So you're tempted to come here and copy this, change that word to length, change that word to length, and say, good, I'm done. But if you find yourself copying a big batch of code, especially you're copying a method, and changing 2 pieces of it, what should you be thinking? It's the same problem. I just need to make the method I have more flexible. So what I'll do here is instead of calling this get level, I'll say get non-negative int. And I'm going to pass in a parameter. Now what parameter should I pass? Okay, and what does that string say? Yeah, I don't know what to call it. I'll call it legend. And down here, we'll do that. So it'll say, if we pass in level, it'll say enter level, : if we pass in length, it'll say enter length. And probably shouldn't call this level anymore. So I'll refactor it and rename it to value or something. Because that just makes a little more sense that way. And then back up to the top, we don't want to call this anymore. We want to call get non-negative int. And we want to pass in level, and do the same thing here. Now, what are some advantages? I mean, it's not that hard to copy and paste and create two methods instead of one, but what are the advantages of having one slightly more complex method instead of two slightly simpler but very similar methods? Yeah?
It's faster, easier to debug.
Yeah, it's, it's easier to debug. If there's a problem in the method, there's only one method to fix. What often happens if you do a bunch of copying and you fix the bug in one place, you may forget to fix it the other places until later. So it's just simpler all around. Your code is shorter, lots of payoffs. All right, so we got a way of getting our level and getting our length. What about the file? We got to create that method. And it's going to have sort of the same structure. I'm going to save some time here, and I'll just make this to do. It's going to be another while true because we're going to be prompting the user until we get a reply. And we've got to call dialogues dot show open file dialog. And that thing returns a file. Okay? So we do a show open file dialog, we get a file back. What do we do next? We said this was similar to this method. What do we do when we got a reply down here? If it's null, we're going to throw a null pointer exception. Let's follow the same convention up here. If the file comes back as null, which means cancel was clicked, we're also going to have this method throw a null pointer exception. We'd rather it be a cancel exception, but whatever, it's going to throw a null pointer exception to indicate cancellation. Okay? What now? What else can go wrong? Yeah? Okay, can this thing throw an exception? Let's see. Yeah, I'm not sure this thing, either the user picked a file or hit cancel. Is there any other case, really? Is there ever any case where we need to prompt them again? Yeah?
File not found exception, if they enter garbage that doesn't match anything.
Yeah, but I don't know if this method here throws a file not found exception. That happens later in the program. So, otherwise, we'll return the file. So that means we really don't need this loop. So I thought we did. Maybe I'm wrong and we'll come back. I didn't think about it too hard before class because I wanted to show you how I think. Okay? So either we're going to throw that exception or we're going to return the file that was chosen. So now we can go back to main. We got a way to get our file, and we can do that, and then we can do this. Now we've got this problem here. New scanner, that can throw a file not found exception. That's something I got to worry about. What else do you need to worry about, though? Is that the only exception you need to worry about catching? Okay, we could get a null pointer exception back from either of these. So I've got a null pointer exception, which means cancel. I've got a file not found exception, which means there was a problem with the file that was chosen. What else? This is a point that some students missed. Yeah?
In the PS5 library, there was actually no legal argument exception.
Exactly. Generate text will throw an illegal argument exception when level is negative, but that can't happen here. When length is negative, and that can't happen here. Or when there's fewer characters, when the size of the file is less than level plus 1. So some of you wrote code to calculate how long the file was, but that was done for you in the this method here. We just need to catch that exception. So that means we need to wrap a try block around this. And start catching exceptions. So what do we do if we get that null pointer exception? It means someone clicked cancel in one of those dialogues up there. We really don't care which one. What do we do? Return. Or really I'll just do return. We're done. If we just put nothing there, it would have the same effect. File not found exception. What do we do when we see that? Well, it didn't say to get another file. It said to do something like that. And what if we get an illegal argument exception? Sort of the same deal, except a different message. Let's say file too short. Okay, so we end up with a pretty simple main, except there's some exceptions that can be thrown. And so there are 3 that we're expecting. If we get 1, we just return because the user canceled. If we get another, we say there was a problem reading the file, or we say the file is too short. So the main is still pretty simple. The reason exceptions are the way they are is it lets you write your mainline code in a compact fashion and handle the exceptional conditions out here on the side where they don't clutter up the main code. And let's try it out. So if I say level 5, okay. If I say garbage for length, it asks for something better, so I'll give it 100. And I got to pick a file. And there's some weird character at the beginning of the file I just picked. But I rewrote generate text, so what it does is it displays the first line of the file and then it echoes out the level and the length just so I can see that it worked correctly, that we passed the right parameters to it. And it seems to have done it. Or if we run it and hit cancel, we're done. Okay, so hopefully you appreciate this process of inventing methods when necessary to keep your code simple. Sometimes you invent a method and get to reuse it, and that's good. Sometimes you don't. But if we didn't have methods, our main method would be really long with a couple of infinite while loops in them, and it gets pretty confusing. Much better to put them off into separate methods so you can deal with them there. Questions? Yeah?
Do you not need to close the scanner that you put the file into?
Okay. So you might ask, okay, you didn't close the scanner, and that's a fair criticism. What would be the way to close it? How would I refactor my code to close it? Well, I'll just do it this way. Instead of opening it the way I did, let's open it this way. Use a try with resources here. Okay, that's cleaner. Thanks for mentioning that. So now we open it so it'll automatically close. Other questions? Yeah.
I think I was one of those people that had to resort to -1, and I can't remember specific. For some reason, when I was debugging it and you hit the cancel button, it was throwing a number formatting exception.
Yeah, it's hard to, I had to look at your code. But what if we had used a -1, returned a -1 to indicate a cancel? What would change about the code? We wouldn't have this catch null pointer exception down here. What would we have instead? Yeah.
We would have if result or whatever equals -1 return.
Right, so if level is less than 0, return. And nothing wrong with that. We just took a different choice. You can make it work either way. I kind of like the succinctness of what we have right there, and keeping the cancellation out here at the extremes. Other questions? Yeah.
Why don't you just write geometry dialog and inside PS5 library of general text?
Why don't I put this inside of there?
Yeah.
Okay. Okay, what's the reason? Why not just put this dialog box, that message, instead of having it throw an exception, why not just put it inside generate text? Yeah.
As it stands right now, generating text can be used in more than one situation. So you can use a different input method than dialog box and output.
Right. We might want to use generate text in a program that's just doing input from the keyboard and output to the terminal, to the console. In which case, it'd be really inappropriate for it to say show message have the show message dialog. Show message dialog is a user interface detail. Generate text is completely unconcerned with that sort of thing. Plus, it was already written. You don't want to mess around with it. Because, one reason I told you not to, the other is when we graded it, we didn't use that implementation of it. We used one that was more conducive to checking your work. So the short answer is it doesn't belong there. Other questions? Yeah?
This one doesn't necessarily have to do with this, but do we also need to know how to use breaks properly?
Breaks?
Yeah.
Well, if you use break, you need to use break. You need to use them properly. I don't tend to use them very often. Let's see. Where could we have used one here? Yeah, there's not really a good. Break will just immediately terminate the loop that it's inside of. But I'd say use break and continue sparingly because they're both kind of confusing. Any other questions? Now, I realize it's been kind of a long example, but believe me, after looking at a bunch of programs last night, this program, I was sure that a lot of you need to hear it. Not everyone, but yeah. Okay, you're saying would you get marked down? Well, so the TAs are grading, are doing the program quality bit of this grading, and basically you get a score from 8 down to 0 depending on how well written the program is. So it's just their judgment over their impression of the code. Any other questions? Okay, so we're now at a dividing line in the course. Up to now, we've been talking about essentially how to implement static methods. After the break, we'll start talking about how to create new classes of data. So, completely different topic. So let's take a break and then we'll do that. right, to this point in the course, we've been using static things inside of classes. So mainly static methods. So you see a static method down here at the bottom that squares its parameter. It's also possible to put into classes static constants. And I haven't had you create any static constants, but you have used them on occasion where they were defined in other classes. So a good example of a static constant is pi. So that's how you create a static constant. You say public final static double pi equals 3.14159. So the key thing is the keyword final. What that means is you can't change the value of pi. If you try to assign a new value to pi, the compiler won't let you. That's because it's a constant. The convention in Java is to spell constants in all caps. That's why I have pi in all caps there. And then finally, it's possible to have static variables. But they're almost always a really bad idea. They have their uses, but their uses are rare. And in this class, it's always going to be a mistake to use a static constant, a static variable. Static constants are another matter, but static variables are bad. I just want to tell you they exist. And I'll show you one reason why they're bad shortly. But yeah, don't use them unless you really know what you're doing. Okay, so that's what classes could contain up to this point. So there are some classes that in the library, the Java library, that basically contain nothing but static constants and static methods. So they exist as a container for static methods. But there are other classes that define new types of data. That's what we're after today. Now you know to access a static constant, you say demo dot, or class name dot constant name. Same thing with variables, same thing with methods. When I say static, that means that if something's a static method, there's one for the class. They're associated with the class. Now here's a very different use of a class. We're defining a class called coords, so think about two-dimensional coordinates. And all of a sudden, our world looks a lot different. There are these things now inside the class called instance variables. And there's this thing called a constructor. So first of all, look at the instance variables. There aren't methods, so you can look at them and tell they aren't methods. They're variables. One's a double, the other's a double. They're private. How do you know they're not static variables or static constants? Well, it's not. Okay, private is a new thing too, but that's not why you know they're not static variables. Yeah? Well, it's in a class, but what is the thing? Yeah?
There's no word static.
No word static. Okay? So people have asked before, what does static mean? So in a class, some variables are static, some aren't. The ones that aren't we call instance variables, if the keyword static is missing. Okay? That's called a constructor. And I haven't explained for you yet what constructors are for. Well, you know what constructors are for, but I haven't talked about instance variables, but I'm just trying to show you the big picture here. Look at that constructor's header, this part right here. And how do you know that's not a method? Yeah?
It's missing a return type.
There's no return type. That's one clue that it's not a method. A method would either have a void return type or it would have a return type, yeah?
Most classes begin with, all classes begin with capital letters.
Okay, so the convention in Java is methods start with a lowercase letter and classes start with uppercase letters. So that doesn't follow that. If that were a method, it would be violating the convention, yeah? Right, the key thing to realize is the name of the constructor is the same thing as the name of the class. It matches. It's coord in both cases. So that's what makes it a constructor. Okay? We'll explain what constructors are for. I'll explain what instructors work, how instructors work later. Constructors. Okay? A class can also contain non-static methods or instance methods. And so an instance method looks a lot like a static method. But what's the giveaway that it's an instance method, not a static method? Doesn't have the word static in it. Okay? So this class definition provides a new class called coordinate. It provides a way to called coord. It defines a new way to it defines a way to create coord objects by using this constructor, and it provides two methods that you can apply to coord objects. So you're used to using constructors to create objects and then invoking methods on those objects, and that's what this class does. It defines a new type, so you can declare variables of type coord. You can now say new coord, and you're calling this constructor. And when you have a coord object, you can say c.getLatitude, c.toString. You can invoke methods on the objects. It's just a new type of data, complete with one constructor and two methods. Just like we spent the last 6 weeks learning how to build, I've told you, writing programs is often about building parts, building pieces. Okay? We were looking at one kind of part last 6 weeks, static methods. Now we're going to look at a different kind of part, new classes of data. So the entire Java library was implemented as a series of classes in this fashion. Okay, and this is what I just said. The instance variables, the constructors, and the non-static methods cooperate to define a new type of data. All right, so here's our definition, just sort of boiled down with some details removed. So that's the definition at the top. At the bottom is the use. So once you define this class, now you can say coord C1 equals new coord. Coord C2 equals new coord. So you can create, there I've created two coord objects. And then in the third line, I call the getLatitude method. I invoke the getLatitude method on the object C1. And so I'm asking, what is C1's latitude? Now, what should it return, do you think? If I tell you that when you construct it, this first parameter is the latitude and the second parameter is the longitude. Right. So when I say give me your latitude C1, it should give me back the 40.28383. And when I say okay C2, convert yourself to a string, it should do something. It should return a string that's formatted in some fashion that is useful. Okay, so that's the game we're playing. Sometimes you need new actions, so you create static methods. Sometimes you need new types of data. Now, when might you want to create a coord class? What type of program would you be writing when you needed it? Yeah?
If you're trying to like design a car, maybe you could
Design what?
like maybe design like an object that has like a car that's moving on like
Okay, so maybe you'd like to, your program's got to keep track of where cars are. You know, in latitude and longitude of cars. Or you're doing mapping software, or you're doing geocaching software, whatever. And you need to represent two-dimensional coordinates. So to make your life easier, you go to the Java library and go, rats, there's no coordinate class. So you create one and then you have it. That happens all the time as you're programming. So there in yellow I've got highlighted, because it says there's a class called coord up there, therefore we're able to declare coord variables down there. Okay, we'll see that those instance variables have something to do with new. And we have seen that the constructor, well, this is showing you that the same thing. The instance variables that I've highlighted there become important when you create a new coord object. We'll see what that means. And here's what it means. So when I say new coord, what's going to happen is the Java virtual machine is going to create in memory for me space to store the values of the instance variables. So basically, every object that we create contains space for the instance variables. And I like to think of it as that rubber stamp right there. So when I say new coord, it stamps out in memory. That's the object. The object is a chunk of memory that has room to store the values of the instance variables. If we say create me a new coord, again, we get a different object somewhere else in memory with space to store a third object, a fourth object. So every time you call new on coord, you're getting a chunk of memory where the latitude and longitude can be stored. So that's the importance of the instance variables. The instance variables say what determine how big the object is in memory, what its footprint memory is. If there's 10 instance variables, then each object that you create with new is going to have space with 10 variables. If there's 2, there's just going to be 2. So that's what new does. Now, let's stop for a second. Why do you think they're called instance variables? And how are they different from static variables? Yeah?
Because they don't exist in memory until you instantiate.
Okay, they don't exist in memory until you instantiate, he said. So that's good. Let's get another take. Yeah?
These are specific for every single object you create.
Okay, so he said they're specific for every object you create. So an object, you can think of an object as being an instance of the class. So until you create the object, there are no instance variables. But every time you create a new object, you've got a new set of instance variables to go with it. So the variables are specific to the object, specific to the instance. Unlike a static variable is shared. It's just one for the class. And that's what's bad about them. They're shared across a lot of code. So that's what happens. Think of that rubber stamp. New means stamp out in memory an object. Now, I've got these little arrows pointing in. Yeah?
So would you use like static int to keep track of how many classes you need?
How many objects you've created, yeah. He just proposed a use for a static variable. If you needed, for example, if you wanted to count how many times a constructor had been called in a class, you could use a static variable for that. But yeah. They have many more wrong uses than correct uses, though. These arrows are meant to represent references. So basically, think of the arrow as being the address in memory of the object. What's going to happen to that arrow? Where's it going to be stored, ultimately? Well, let's keep that in mind as we can figure it out. Okay, so that's the new part. Now, so what we're looking at right now is what happens when we execute the code like this. So the first thing is we have to create a new coord object in memory. What's the next thing that has to happen? Are we done creating the object once we've stamped it out in memory? Maybe back there.
If the constructor is passing in values, then it sets whatever those values are
Right.
to the fields.
So the next thing that happens is the constructor runs and fills in those variables, fills in the fields, fills in the instance variables for that object. Otherwise, they won't have any values. So let's look at that. There's our constructor. We're calling that. First thing we do is we stamp out in memory space for the instance variables. And then what's going to happen? What's the constructor going to do? Basically, the constructor runs and starts dealing with that structure over there. So what's the constructor going to do? You can see the code of the constructor up there. So, right, it's going to take the value of that variable right there and store it into latitude. And latitude is referring to this box down here right now, because this is the one we're constructing. And same thing for longitude. So latitude and longitude get initialized. So that's what a constructor does. So the new creates the object in memory. Then the constructor gets a chance to initialize memory. Now we have a fully constructed object, and we have a reference to it, an address. What happens to the address? Consider this statement in totality. You can think of this as returning a newly constructed and initialized object, a reference to a newly constructed initialized object. What happens to that reference? It's stored into C1. So a variable like C1, that's not a primitive variable, primitive value, contains a reference to an object. So that's how, I've just shown you what happens when you create an object and store it in a variable. Okay. Now what's going to happen when we do that? Same thing. Object is stamped out in memory. Constructor runs, and this time it's initializing that latitude and that longitude. and it's stored in a different variable. So now we've got two objects, each referred to by a different variable. Okay. Now, let's try to figure out what happens when we do this third line down here. We call C1.getLatitude. So here's our picture. We constructed C1 and C2. They're referring to different objects. And we call C1.getLatitude. Let's watch what happens. Okay, now, there's a keyword called this in Java that we really haven't confronted up to now. And when you invoke an instance variable, in addition to the parameter, an instance method rather, in addition to the parameters, of which there are none in this case, in addition to the local variables, of which there are none in this case, there's always a thing called this. And this refers to the object on which the method was invoked. Okay? It's called the implicit parameter. It's the object on which the method was invoked. So when we say C1.getLatitude, yes, we are calling getLatitude. But what happens is, inside this method here, this keyword this is going to refer to the same object. It's going to refer to the object on which getLatitude was invoked this time. So C1 refers to this object, so this refers to this object. Okay, that's very important to remember. That same thing holds in a constructor. In a constructor, the object that's being initialized is referred to by a keyword this. Inside an instance method, this is always defined. It's always the object on which the method was invoked. Now, these 8 words, the object on which the method was invoked, I will keep trying to hammer this into your head, that that's what this means. This is the object in which the method was invoked, or the object in which the constructor was invoked. And that's going to be the answer to a question on the final, not the midterm. Midterm won't cover this lecture, but it will. I promise you there'll be a question on the final where the answer is the object in which the method was invoked, and people will still miss it. And that's not the last time I'll tell you. Okay, now let's see what that means. So when you see the instance variable up here where it says return latitude, that is actually a shorthand for this.latitude. So now we can look at the getLatitude method, and tell me what that return statement says now. What does getLatitude return? Okay, well, you forget about C1 or C2. If you just look at the code before it's being run, and someone says, what does that thing return? And you say, oh, it returns latitude. What's someone going to ask you if you say that method returns the latitude?
Which latitude?
The latitude of what? And what's the answer? Right, it returns the latitude of the object of which the method was invoked. That's answered a lot of questions. So when we say C1.getLatitude, C1.getLatitude, what's happening is that method is going to this. It has a reference to this, so it goes over there, it extracts the latitude value and returns it. When we do C2.getLatitude, this time we're invoking it on C. And so while getLatitude is running, this is going to be referring to the same thing as C2. Excuse me. And so it'll return the 80.87 value instead. But we're at the end. You don't often see this in the code. But anytime you see an instance variable in the code, it's shorthand for this.instance variable. But it's not required. It's the implicit parameter for a reason. You don't often see it. But to really understand what's going on, you got to realize it's implicitly there. Let's look at some code. I'm sorry it's been like a week like this, so harder on me than you. Here is a class. This is about the simplest class you can create. Core 1. Defines a new type of object. Now, the class body is completely empty. Normally, you would put a constructor and some instance variables in there. This one has no instance variables, it has no constructor. It turns out that by default, if you don't provide a constructor, Java will provide one for you, and it's a constructor that takes no parameters and does nothing. Okay, so you got that. So when you call new chord 1, what's going to happen? What's going to get stamped out in memory? Now, I told you there would be space for storing the instance variables, and there aren't any, so you might think you get reference to an empty spot in memory. Turns out there's some extra stuff that goes with every object in addition to the instance variable, so it would just contain that. And nothing else. So it's not a very interesting class, but it would work. So let's go up a level. Here's another version. Chord 2. It contains 2 instance variables that are public. Now, I didn't make a big deal about public versus private yet. You do not ever want to make your instance variables public. Big mistake. They need to be private. And let me explain the difference. So let's run JShell. Come on. Let's see if chord 2 is going to work for me. Okay, so I have created a new chord 2 object. Now, since lat and long are public, that means that I can directly do something like this. I can say c.lat. Turns out it's initialized as 0. c.long. So I can directly look up the values of instance variables. I can do c.lat gets 5. And now if I look at c.lat, it's been changed to 5. So you might think that's useful, to be able to directly access the values of instance variables and modify the values of instance variables. But it's a bad habit to get into for reasons I'll explain later. So let's just take that as an example of something you shouldn't do. Here's a different version where the variables are still public, but now we have a constructor that makes sure that the values are valid and then saves them away. So what's going to happen when we say chord 3c equals new chord 3, 85, 110. Okay, let's see. It'll create it for us. If we say what is the latitude, it'll tell us 85. If we ask for longitude, it'll tell us 110. But it's possible to change them. How do we make it so it's impossible? If you just take my word for it that you do not want to have these variables accessible from outside of the class, how are we going to make it so that they are inaccessible from outside the class? Yeah?
Change public to private.
Right, we just make them private. So all I changed here was I made them private, and everything else is the same. But what I've done now is add methods to extract the latitude and longitude. That's how you get their values, is by going through methods. And again, I haven't really justified why I'm making you type more than you had to type before. But let's come down here. Spelled it wrong. Okay, now if I say, okay, what's c.lat? It's going to say no, that's private. What's c.long is going to tell me no, that's private. What I have to do is invoke an instance method. So I will say, okay, give me the latitude, please. And I can do the same thing with longitude. Now, right off the bat, let's see if we can come up with a reason why you might want to make, the reason why you do want to make instance variables private. What is it impossible to do with coordinate 4 that it was possible to do with coordinate 3? Yeah.
Change the value outside of the class.
Right. There's no way to, in coordinate 3, there's no way to go in and change the latitude and longitude of an object. There was in coordinate 3 because the instance variables were public. As the designer of a class, we're the ones that decide whether whether objects are mutable. Maybe we don't want latitude and longitude to ever change. We can enforce that by making the instance variables private and not providing a way to change the latitude and longitude. Now, what if we decided, I'd like a way to change the latitude but not the longitude? What would we have to add to the class to make that possible? Without making the instance variables public. Yeah?
A way to assign the values.
Okay, well, but what will we add?
A method.
Yeah, we add a method. So we would do something like public void set latitude. Lat. And then we could say something like latitude equals lat. And what did I do wrong here? No, it's called lat. All right, well, that's good. Now, this raises a problem, though. The instance variable is called lat. This variable is too. So what does lat refer to? Does it refer to that variable right there, which is called lat, or does it refer to the instance variable's lat? The general rule in Java is it looks for the closest definition. So what would that imply here? Both of these are referring to that variable. So this isn't accomplishing what we want. So what are we to do? We could change the name of the instance variable, but what's another solution?
Use this.
Use this. Right. We just do this instead. That makes clear that we want to take the value of lat right here and store it in the lat of what? In 8 words or less. The object in which the method was invoked. So this refers to the lat instance variable of the object in which the method was invoked. This refers to the parameter lat. I usually try to name the instance variables more distinctively so this doesn't happen, but it's good to see this example pop up. Okay, let's look at our last version of coord. So good, we have a class. We have the private instance variables. They always need to be private. We have the constructor just like before. We have a way to obtain the latitude of an object. We have a way to obtain the longitude of an object. And we have a way to obtain, we implemented the toString method. So what's going to happen, let me do this for you. Now, before, what was happening every time we created one? Let's say we created a coord 4. It displayed it that way. Anyone know why it's displaying it that way? Turns out it's the address in memory where the object is stored. So it's saying it's a coord 4 object that's stored, and it's in hex. So it's 6C498225B. I don't think it's a real address. It's an abstract address in the virtual machine. But anyway, it's effectively an address. Turns out that every class you create automatically has a toString method. And what it does by default is it prints out the type of the object, followed by the axon, followed by the address in memory. So here we create a coord 5, and we got a much more friendly representation of the object. What changed? Why are we getting a nicer picture? Yeah.
You defined the toString method.
Right. We added a toString method to the class. So now whenever it needs So what happens is, what JShell does, when it needs to display the value of an object, it calls the object's toString method and displays that. And so now that we provided one, we get a much more reasonable thing to look at. So all it's doing is it's taking, putting the square bracket, appending the latitude, sticking in a comma, the longitude in the closing square bracket. So now we have a pretty nice class that'll at least let you glue together two values into a coordinate. And that's our starting point. Long way to go, but hopefully you start to see the idea.